Section 2.3a, real zeros of polynomial functions. We're going to start here by reviewing long division and synthetic division. Remember, in long division, when we take and we divide, let's take something as simple as 5 and dividing it into 243. We start by asking ourselves the question, does 5 divide into 2? No. Does 5 divide into 24? Yes. How many times? It goes 4 times. Then we multiply. 4 times 5 is 20. Then what do? We subtract that value off. We bring down the next value if necessary, which it should be. 5 goes into 43 then. 8 times, we multiply. 8 times 5 is 40. We subtract that off. This represents our remainder, which is a fraction over the divisor, what we are dividing by. That process of long division is exactly the same thing as what we're going to do when we long divide polynomials. We're taking x minus 2, and we are dividing that into 6x cubed minus 19x squared plus 16x minus 4. Now, when we do division with polynomials here, we are only looking at the first term of the polynomial we're dividing by. You're asking yourself the question, what times x equals 6x cubed? That is 6x squared. Then we do the same thing we did over there when we took the 4 times 5. We take 6x squared times this whole thing, so we have to distribute it through. We get 6x cubed minus 12x squared. And then we do the same thing. We subtract that whole thing off. 6x cubed minus 6x cubed is gone. Negative 19x squared plus 12x squared gives me negative 7x squared. What times x equals negative 7x squared? That's negative 7x. Again, multiply negative 7x times x. Negative 7x times negative 2. And we subtract all that off. Squared terms are gone. We have 16x up here. Minus 14x gives us 2x. So now what times x equals 2x? 2. Multiply, we get 2x minus 4 when we distribute that. Subtract that all off. X's are gone. The 4 from up here, negative 4 plus 4 is 0. So we have a remainder of 0. What does that remainder of 0 tell us? Tells us that x minus 2 is a factor of that polynomial. Remember, the definition of a factor is that it divides in evenly. X minus 2 did divide in evenly. There's what we get when we divide that polynomial by x minus 2. Letter B, x minus 1 into x cubed minus 1. I'm going to leave some spaces here. Not necessary to do this, but it helps you line up like terms. In other words, we have no x squareds, we have no x's, and then we have a constant of minus 1 out here at the end. So now begin. What times x equals x squared? Or I'm sorry, what times x equals x cubed? That is x squared. Multiply, we get x squared, or x cubed minus x squared. Subtract that all off. Cubes are gone. Remember, we have a 0x squared up here, even though it's not written. So 0 plus 1 gives us x squared. What times x equals x squared? X, multiply, x squared minus x. Subtract all that off. X squared minus x squared is gone. 0x, which is up here, plus x gives us just an x. And now what times x equals x? 1. Distribute that to our divisor. 1 times x, 1 times negative 1. Subtract that off. X's cancel. Negative 1 plus 1 cancels. We're left again with a remainder of 0. What does that remainder of 0 tell us? Again, we know that this is a factor of that polynomial because it divided in evenly. Letter C, x squared plus 2x minus 3. Dividing that into 2x to the 4th plus 4x cubed minus 5x squared plus 3x minus 2. Remember, you're only looking at the first term here, so I'm only looking at the x squared here. What times x squared equals 2x to the 4th? 2x squared. Multiply. We need to distribute it to all three terms here in our divisor. We get 2x to the 4th plus 4x cubed minus 6x squared. Subtract all that off. 2x to the 4th minus 2x to the 4th is gone. 4x cubed minus 4x cubed is gone. Negative 5x squared plus 6x squared leaves us with just x squared. What times x squared equals x squared? 1. Distribute that 1 through, we get x squared plus 2x minus 3. Subtract. X squared minus x squared is gone. 3x minus 2x is x. Negative 2 plus 3 is 1. Now, as soon as you get something that you are left with down here, which is of less degree than what you are dividing by, here we're dividing by a degree 2 polynomial. Here we only have degree 1. This now represents your remainder. So as soon as you get a less degree polynomial than what you're dividing by, that is your remainder. And we write our remainder as a part of the divisor. So our remainder is x plus 1 over x squared plus 2x minus 3. So that's long division. Synthetic division now. Synthetic division is a preferable way of dividing just because it's quicker. However, you're going to have to know how to do long division because synthetic division is only useful if the polynomial you're dividing by is degree 1. In synthetic division, we want to divide by the solution that is produced by the divisor. In this case, x minus 2 would produce a solution of 2. So that is what we are going to synthetically divide by. To set up your synthetic division, the divisor or the solution produced by the divisor goes in our box. Then our lead coefficients of what we are dividing into get written next to that box. So 6, negative 19, 16, and negative 4. To do our synthetic division, we bring this first number down. So I bring the 6 down, and now we multiply. I take 2 times 6, which is 12, and we add down that column. Negative 19 plus 12 is negative 7. We multiply again. I take 2 times negative 7 is negative 14. Add down the column. And 2 times 2 is 4. Add down the column. We get 0. This last number in our synthetic division always represents whatever your remainder is. Because we have a remainder of 0, that tells us again that this polynomial is a factor of what we divided by. What these numbers here now represent are the new polynomial that we get through the division process. This polynomial will always be 1 degree less than what we started with. So we started with 6x cubed. This is going to represent 6x squared minus 7x plus 2. And if you look back at the very first problem that we did today, It's the exact same problem we just did here by synthetic division, which was here, and notice we got 6x squared minus 7x plus 2 when we divided it long way, or through synthetic division. So if it is a linear factor you are dividing by, it's going to be a little bit quicker if you use synthetic division, but understand you're going to have to know the long division process later on when we talk about rational functions in order to find slant asymptotes when the divisor is not linear. Solution that x plus 3 would produce is negative 3. Now, here's the one thing you need to be careful of in synthetic division. You must write your polynomial in descending order. So there's my x to the 4th coefficient. My x cubed coefficient is 0. If you do not put in that 0 for that term that is not accounted for, you will never get a synthetic division problem correct that is missing a term. Negative 10 is my x squared, negative 2 is my x, and 4 is my constant. Once you remember to put in that 0, it's just a matter of going through the synthetic division process. Bring the 1 down, multiply, add down the column, multiply, add down the column, multiply, and so on. Okay, this time we didn't get a remainder of 0. Remember, this last value always is your remainder, which tells us since we have a remainder that x plus 3 is not a factor of this polynomial. The polynomial then that we are left with is 1 degree less than what we started with. We started with a degree 4. So this is going to be x cubed minus 3x squared minus x plus 1 plus our remainder over our divisor. Number 3. Evaluate this function when x equals 2. Okay? Up until this point, when you've been asked to evaluate function notation, what would you do? You would take 2, negative 2, I'm sorry, plug it in every spot here. Plug all that into your calculator, simplify, and that would give you the value of f of negative 2. It's one way of doing it. Another way of doing it, and you will have to do it this other way, is through synthetic division. Take whatever you want to evaluate the function at, in this case negative 2. Put that value in your synthetic division box. And go ahead and go through and synthetically divide. Bring the 3 down. We get negative 9. If you plugged all that into your calculator, you're going to get negative 9 as the solution for f of negative 2. Through synthetic division, whatever your remainder is also the function evaluated at whatever you are dividing by. So in this case, if I didn't do any of this that's shown here in blue, and I just synthetically divided by negative 2, and I got negative 9 as the remainder, I would know that f of negative 2 is equal to negative 9. So when you get to those problems in the homework, I do not want you plugging into your calculator what we have here in blue. I want you synthetically dividing by what you are evaluating the function at, and then given this relationship down here. Do not just circle the remainder. Tell what it means. In this case, we know f of negative 2 equals negative 9.